Alright guys, so I'm going to do another example for you guys. And they're giving you this maclaurin series, and they're asking a few questions. This is kind of like maybe a free response that you could get, or some of the parts could be similar to a free response that you guys would get on the AP test. So we want to do a couple things here, and I'm going to give you some help with doing this. This is, again, Taylor polynomials and maclaurin series. Maclaurin means it's always centered at 0, and you can see these are all centered at 0. So let's get to it. So the first part is they want you to find f prime of 0. So now, going back to the formula, like your f prime, like anything, right? If it's a power 1, power 2, power 3, those are all really your derivatives, right? Because if we were asking for the third order or fourth order, you take the fourth derivative. So when you're looking at prime, I'm looking at this first term here, okay? And the way you would set it up is, so if I know that my f prime of 0 is going to equal, f prime of 0 x, right? Say I'm setting it up, I would have f prime of 0 x is going to equal that term, x over 2 factorial. Well, that becomes pretty simple because the x's wind up canceling out, and you get f prime of 0 is going to equal 1 over 2 factorial, which in our situation, right, that's very simple because that's just 1/2. So f prime of 0 in this case is going to equal 1/2. Okay, so that's the first part. Now, let's go to this one. Now, I'm going to use a different piece of paper here, and they want to know the 10th derivative at 0. Okay, they want to know what that equals. So, I'm bringing this back in, right, and I have x to the n over n plus 1. Okay, so knowing that, right, x to the n over n plus 1, right, if we plug in 10, we could use that. All right, but real quick, okay, just so you get the idea, like this one, I did have this over 1 factorial, which is 1. So, I mean, I know I didn't put that there, but that was really there where we have this. So let's think of this the same way, right? So if I'm doing this problem, I would have f to the 10th derivative 0, and then you guys know that this would be over 10 factorial and times x to the 10th, just based on our Taylor polynomial or our maclaurin series centered at 0. Now, because their function that they gave us was this, I'm going to plug in 10 and set those two equal. So, right, x to the 10th over, now this will be 11 factorial. So it's a little bit different here, right? But again, what cancels out would be our x to the 10th, right? Cancels out, so you're left with this. Okay, after the 10s will cancel, x to the 10th will cancel out. Now, how do you solve? Now, I'm just going to multiply both sides by 10 factorial. So I get this notation. This is kind of weird, but what it really means is that you have 10 times 9 times 8 times 7 ... 3, 2, 1, all over 11 times 10 times 9 times 8 ... 3, 2, 1. And you could see what's going to wind up canceling is that 10 factorial cancels out for both top and bottom, and you're just left with 1 over 11. So that would be what our 10th derivative at 0 would equal 1 over 11. Okay, so those are those first two that you are looking for, which are very nice, easy problems, but you got to get used to understanding the notation, right? So this is our notation. We always know that this would be the setup, and if it equals that, we just solving for the derivative, the 10th derivative at 0. Okay, next one we have is they're saying let g of x equal x f of x. Okay, so what does that mean? If this is our f of x, we're just multiplying every single term in here by x. okay? So I'm taking that whole thing, right, and multiplying everything by x. So what it'll look like is, so g of x, right, equals x times this whole and so on. So I'm just distributing. So I'll get x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot 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 plus x to the n plus 1 over n plus 1 factorial, okay? Also, you know that in there would also be that other term, right? Like in between here, you would still have x to the n over n factorial would also be in there. The reason why I'm showing you that is leading into this next question that we have, where we have to figure out, well, what function would this represent? So this is where I shared with you guys the common maclaurin or Taylor series or Taylor polynomials. And this is one that you want to be familiar with, okay? So when they're saying what a familiar function is, well, we know that like e to the x, okay, is going to equal 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. And then you get that notation that we have, and that would be e to the x. Now, the only difference here and here, right, you could even see is that they don't have the 1 that's written there. And which is very nice, you could just subtract 1 from this, right? And you would wind up with that. So that's what this is going to wind up, e to the x minus 1 would represent g of x.